'cause there are days,
There are days.
well, there are days,
There are days.
and there are days when I do just fine. I dress real nice, put in my 9 to 5. I go right home, make sure the dog is fed. I drink some herbal tea and I head straight to bed. 'Cause there are days,
There are days.
well, there are days,
There are days.
well, there are days,
There are days.
well, there are days,
There are days.
there are days. We all have one life to live. One day we will die. It's true that life, it is a gift, but we treat it like a right. We all start as little kids, hope bright in our eyes. Then one day our heads grow big. Now we slowly lose our sight. And I'm sorry for the harm we've done, and I won't give up the fight. Our swan song is a selfish one, and we're running out of time. yet. And I'm sorry for the harm we've done, and I won't give up the fight, 'cause our swan song is a
Hello again, everybody, and welcome to another Geo-Institute live stream. It is, of course, day 4 of Geopalooza, if you are tracking that kind of thing. And our showpiece for today is this very event, which you find yourself watching as we speak. My name is Brad Keeler. I'm the director of the Geo-Institute, and this is episode 2 of the Keller Sustainability Series. If you, for some reason, did not catch episode 1 with Keller's own Kimberly Martin talking about, well, many things, but in particular the UN Sustainable Development Goals, you can go back on our YouTube channel and enjoy that after you watch this today. If you don't know anything about the Geo-Institute, we are a technical society with about 12,000 members, most of whom are geotechnical engineers and/or geologists, and that we are part of the American Society of Civil Engineers, and you can find out a lot more information by heading over to geoinstitute.org. And if you like what you see today, and I sincerely hope that you will, dear viewer, you should click like, subscribe, and get notifications, and we will let you know every single time we post. I almost said paste something to the YouTube channel. Our MC for today, as we always find him, mustache on his upper lip, sitting in front of that glorious wheat field in rural Saskatchewan, celebrating the sustainability series from Keller on the west coast of America. It is Tim Avery. He will introduce our speaker for today. Thank you for doing this, Tim, and welcome, Stacy. We're going to have a lot of fun.
Thanks, Brad. It's my pleasure to be doing this once again. So I'd like to introduce our speaker today, Stacy Smedley. Stacy, if we just go into some of the nitty-gritties, has her BA in Architecture and Arts from the University of Washington. Presently, I had to boil down a lot of stuff for this, but presently she's wearing, I think, 5 hats, which includes being on 2 advisory panels, presenter on sustainable design, musician, and you just heard her and her band, the Magnolia Steel, on the intro, and she's the executive director of Building Transparency. Building Transparency was established to manage and develop the Embodied Carbon and Construction Calculator, EC3, which was the collaborative result of nearly 50 industry partners. This also, for us geotechs, can be used in our industry for calculating the carbon footprint and carbon of foundation work and construction work. Prior to this, she was with Skanska for 9.5 years, all in sustainability roles. First as pre-con manager, then director, and finally senior director. Along the way, she's also chaired several committees and task forces, been an advisor, co-founder, executive director of the SEED Collaborative, named by ENR as one of the top 25 newsmakers in 2018, volunteer in sustainability, education, and practice, guest editor of Green Building and Design Magazine, recruitment chair at U.S. Green Building Council, associate architect at KMD, owner of SAH Design, specifications writer, project engineer, designer, and dog owner. In this session, Stacy Smedley will share more about the nonprofit and its suite of solutions, helping arm building industry professionals with the information they need to set achievable carbon reduction targets, select low carbon materials, and reduce the sector's overall impact on climate change. She will highlight the organization's cornerstone tool, the Embodied Carbon and Construction Calculator, which is a free and easy to use tool to empower users to benchmark, assess, and reduce embodied carbon. Learn more about the tool and the nonprofit's mission from Stacy Smedley. Thank you, Stacy.
Thank you. I'll go ahead and just share my screen and dig right in. I've got a lot to say and not as much time ever as I would like to have to say it. So I'm going to go ahead and find the right screen. There we go. Hopefully you can see my screen now. And the slides. Thumbs up, Tim, looks good. I'm gonna assume so.
Sorry about that. My mic was off. All good.
Okay, all right. So I'm happy to be here today. We've already had fun on the kind of presentation team site. So I'm happy to be sharing today. I will say I do have dogs, as was mentioned, and they may make an appearance, or I might have to run and let the 5-month-old puppy out. So apologies in advance if that happens. But I'm here today to talk to you about really the story of how I got to where I am now. I won't go through all the things that Tim said explicitly, but how I landed in a place where my whole job is to really understand embodied carbon emissions of construction materials and do everything I can to provide the tools and data necessary to everyone else in this industry to decarbonize them. Just first, a little bit about building transparency. We are a 501c3 based in Seattle, Washington, but with employees all over the country. So we are a virtual organization. We started in 2020, right before COVID. And our core mission is provide the open access data and tools necessary to enable broad and swift action across the industry when it comes to addressing embodied carbon's role in climate change. So I'm going to walk you through how we do that today and really focus on really what embodied carbon is and the data that we're using, but also just giving you a flavor of the tools that we offer and the data that we provide to help the industry tackle this problem. Just a little bit about who supports us. I'm really proud of this for a couple of reasons. First, just having a software that is a free open access tool and a database and a nonprofit is not a typical model for software development. So we rely on all of our partners and sponsors to basically pay for the tool and the database to be free for everyone else. So everyone on the screen is using the tool in some way, either as an owner creating policy and using it for benchmarking, architects, engineers, and contractors actually doing the work to specify, procure, and track low carbon materials, other software platforms that are leveraging our data and want to support the data and the curation of it. And then at the bottom, all of the industry orgs and manufacturers that want to ensure that the data in the tool is well represented for their sector or their industry and want to support that data being available to everyone. So it really is all hands on deck when it comes to what we have to do with embodied carbon. And we're very proud of our funding base really representing that. Then I always go way back to the why and all of this, and it's called the Sustainability Series. So hopefully these images are going to be things that you would point back to climate change. But in the past, and I think still today, most people call all of these things natural disasters because that's what they are. But in reality, the way that I think of them now is as human-made disasters, because the increase that we're seeing in all the things on the screen are being caused by the way that we're choosing to make and consume things. And if you think about the emissions that are pointing to climate change and increasing, and then you think about our human consumption, that's where these things all intersect. Everything on this screen either consumes energy, which creates emissions, or consumes materials or manufacturing ingredients, supply chain, which also creates emissions in terms of how we do all the extraction and manufacturing and disposal. So this is really what's causing those man-made disasters that we're experiencing at a greater intensity today. And again, the reason why this is so important is that we've set these targets. The Paris Agreement was the one that was the most notable. We were trying to stay under 1.5 degrees Celsius warming. We have now passed that last year in a consistent way, where we are now basically exceeding the commitment we made or the targets that we made. And so we have to go do what we can to mitigate the worst impacts as urgently as we can. And just to have this kind of foundational in your minds, the reason why it's important that this kind of low temperature increase we're currently experiencing is because at under 2 degrees Celsius warming, all the things I've outlined in red are things that are triggered, and things that once they are triggered are hard to recover from. So just having that in your brains as you're thinking through how the way that you can impact and reduce the carbon emissions of construction materials and the work that you do directly influences and helps ensure that these things don't happen. So again, my deep dive into all of this was during my time at Skanska. Skanska is a global general contractor, European and North American based, with many offices, but based in Sweden, and put out these forward-thinking carbon emissions targets when I was there as a sustainability director. And what you'll see here is it's 0% by 2045. And that includes the embodied carbon emissions of things like concrete and asphalt that we were purchasing and putting into the projects that we built. So I was tasked as a member of the small sustainability group to really start to figure out how we could account for those emissions of things like concrete and steel, how big were the impacts, and really how could we then start to reducing them to meet this target by 2045 of 0. At the same time, we were building for customers that were also looking at this exact same scope of emissions of the materials that we were putting into their buildings and trying to set targets to get to 0. Meta's is the most prolific one, I think, in terms of timing, where they're trying to get to 0 across their value chain by 2030. That's not very far away. And so what we started to have to do is ask this question: what is embodied carbon? And really, for me, how can I help reduce it for my company and all those other customers? And the first thing that we did was really start to try to benchmark this. And, you know, when you look at this now consistently across any company that is tracking these scope 3 emissions, that's where the embodied carbon emissions live. It's the emissions of what you buy. And we're buying construction materials. It's consistently over 90% of a company's carbon footprint. So if you're committing to 0 and you're including those emissions, that's really where you need to focus your time and attention to make the biggest impact and to meet your targets. So just to walk you through these emissions, there's so many terms, but I'm going to do this kind of quickly. I'll share the slide deck. When we look at these scopes of emissions and how they're reported, again, 90% are in scope 3. What you're going to see is supply chain emissions of everything that we make, manufacture, and then buy are in the scope 3 bucket. So the extraction, production, and then the waste stream, all these things that are still highlighted are really what we're focused on when you think about the construction material value chain. And as I dug into this, what I found is that the way that we were accounting for this stuff largely as a global sector and industry, inside and outside of construction, was taking the dollars we spent on construction materials times some average value to get just a kind of ballpark number, kind of dart in the dartboard of what these scope 3 emissions were. And what that means, that it wasn't the materials that you bought times the actual emissions of what they emitted. It was this very kind of average number. And so the move now with embodied carbon emissions and accounting, and what I'll show you EC3 does, is to get to this actual accounting so we know exactly how much we're emitting, and we can actually incentivize reduction of emissions between suppliers based on knowing that. The other reason this is so important is because the building sector is a huge piece of global carbon emissions, and building materials and construction. Sorry, there's Chuck on the counter behind me. Building materials and construction are 11% of that pie. So everything you're seeing in that picture right there when it comes to how we manufacture and install construction materials is 11% of global carbon emissions. So that's a big enough chunk in terms of the grand scheme of getting to 0 and meeting those climate targets that we really do need to be focused on it. And just to put one more kind of perspective on it, if we know it's 11% of global carbon emissions, probably more than that now, we are building at a rate where those numbers are largely going to increase, with over 2 trillion square feet of construction of buildings and infrastructure over the next 30 years, 3 decades. So if you think about an entire New York City of materials being made and put into projects every month, you can understand kind of the scope and the scale of what we're talking about here. So the next thing I like to do is just walk you through and visualize these emissions. I will tell you, when I sit here at my desk and I'm looking at the windows and the gypsum board around me, or I'm walking down the street, I now see CO2 emissions popping out, little bubbles everywhere, because I now am thinking about this constantly. But just to help get this in your brains, you know, really, you think about how we make something like concrete or mass timber board. It starts with the extraction of those materials at a extraction site where we're using equipment that is burning fuel and releasing emissions to extract the raw ingredients. We're then transporting them to manufacturing facilities where we're using, again, vehicles that consume fuel to get them to those facilities. There's then process emissions at those facilities, either energy consumption or the emissions of making something like cement that releases CO2 that goes into the atmosphere. That's where most of the emissions live. Then there's the transportation of those materials to a construction site with fuels that consume diesel or gas that release emissions. And then again, equipment that's installing them on a site. So this is really what I see now when I look at a concrete road or a mass timber building. Really anything that we make, there's CO2 emissions along this whole value chain of how we make it. The next thing I'll say before I get even more technical and detailed when it comes to all the 3-letter acronyms and the way that we account for this stuff is that This is a saying that my mom used to say to me when I was growing up, that life is like an onion. You peel it back one layer at a time, and sometimes you weep. Um, I like to say embodied carbon is like an onion. We're peeling back the layers of all this and understanding it and getting deeper into it so that we can actually decarbonize how we make things. But it is painful sometimes. There's a lot to learn and a lot to actually be able to understand. And sometimes I have shed a tear when trying to dig into all of this data and figure out how we were going to tackle this problem. So it's okay. Just know that one layer at a time is really an okay way to approach this wherever you're starting from, whether you're at the outer layer of hearing these things for the first time or trying to dig into some of the technical aspects of the data. So we're going to dig into embodied carbon emissions. Put on your goggles, try not to cry, and I'll do my best to explain this relatively quickly so we have time for questions. So the first thing I did at Skanska, once I understood this kind of scale of impact and I was tasked with understanding or figuring out how we were going to actually reduce emissions of these materials, I did come from the cost estimating department when I first started, and I started to figure out or think about how we could have carbon as a currency just like we have cost. With cost estimating early on, you'll use average factors for things like concrete and steel or other piping, whatever you might be looking at, and a quantity to say, okay, this is the rough order of magnitude of the cost of this. And then as you get into specification and procurement, you'll get down all the way to the actual cost per unit of that product from that manufacturer that you're about to purchase. And so my hypothesis was, what if we had carbon intensity values per unit of material, just like we did for costs? We could start with averages or ranges and then get to the actual supplier carbon content, so that when we're looking at cost, we could also be looking at carbon when we're making our choices. What I had to find was those carbon intensity numbers that were product and plant and manufacturer specific. So I did what everyone does. I went to Google and I Googled product specific carbon emissions data for concrete and steel. What I found were environmental product declarations. They are third-party verified documents that do life cycle assessments of a material at a plant, very specific, following ISO standards and product category rules that are then pushed to a third-party verifier, someone like ASTM, UL, NSF, to review all the information and make sure it's accurate. And then it has to be publicly published. So for me, it was this best-in-class source of truth where I knew I was getting to the carbon intensity value per unit of material, that it was verified, not self-disclosed, and that it was public. I could find these documents, these PDFs, all over the internet for various construction materials that gave me this magical little table on page 5 or 6. So I started collating those together. What helped me was to actually think about this as an environmental impact nutrition label for a material. So just like you have a serving size on a box of cereal of carbs, where you might go and say, okay, I'm on a keto diet, I'm on a low carb diet. So I'm going to compare the carbohydrate content, per 3/4 cup of my Cheerios versus my Cashy. And I'm going to pick the lower carbon option because I want to reduce my carbs. Well, it's exactly the same with environmental product declarations for building materials. You can say I want to go on a low carbon diet, and you can compare the carbon values per serving size to pick the lowest carbon option for your concrete or your steel or your pipe or your foam. So that's really the magic unlock for me, was finding the source of data. Again, so what I did was I started downloading all these PDF documents from manufacturer websites and verifier databases, putting them into folders, and then creating an Excel spreadsheet where I could go and compare and sort and find. And this took hours of time. And so Skanska had a seed innovation fund that employees could apply for if they had an idea that would impact Skanska's work in a positive way, but also the larger industry. And so I thought to myself, what if I could actually take all of this data that was in PDF documents all over the internet that I'm putting into a spreadsheet that's taking me weeks and months, and digitize all of it into a place where no one else has to do that ever again. And then how could we access that data to do that comparison and accounting that I was looking to do? What resulted was EC3, so the Embodied Carbon and Construction Calculator, or EC3 tool. These are the bullet points that I put in the list when I went in for the innovation grant. It's a free, open access, transparent, easy to use, industry-led, supply chain focused, embodied carbon and construction calculator. I co-conceived of the tool with a software development partner named Sea Change Labs out of Canada, who still develops the tool today. And then we were able to incubate it at the Carbon Leadership Forum with over 50 partners, giving funding to support the idea of having this tool out there for use in the industry. So just a little bit about the tool. I'm just going to show some screenshots. I'm not going to do a deep technical demo, but anyone can go register for the tool at buildingtransparency.org. It's free. You just put in your email address and the password, and you get a confirmation link, and you can go do what I'm about to show you. So first of all, that magical idea of digitizing EPDs. This is what an EPD looks like within EC3's database, where you can see we've taken all those fields out of the PDFs and stuck it into a digital format that's standard. So anyone can go and view the information this way, but also download that PDF document. And then what you can do once you're logged in is begin to find and compare materials based on these carbon intensity values. So starting with just going through what it looks like to open up the tree, you can see all of the different categories that we currently have, either in pilot or public versions of the tool. This is going into ready mix concrete. And then being able to do things like set the compressive strength or other performance specifications that are specific to concrete, set a geography like Washington State, and then click the search button. And it will return to you in a matter of seconds the list of every single manufacturer and product specific EPD for a ready mix of your choosing. So what you're seeing here is a list of all the different EPDs. From the left to the right, there's the manufacturer, the plant location, the product number for the mix ID, the description of the mix, the strength, and then the carbon content per unit. And you can sort these low to high. You can click on that compare button like I'm showing here and get to a list of all the different suppliers, how many EPDs they have for that mix design type, and what they're doing, how they're performing on a carbon intensity value. So that little cartoon graphic that I had made where I was showing the comparisons between them and how to select is really what led to this in many ways. If I was going to procure concrete in Seattle, I would look at this and say, okay, Cadman and Stoneway are the best performers right now for all of their mixes from an emissions perspective. I at least want to make sure they're included in my bid so I can get them to compete on their carbon emissions of their mixes and their costs, and really start from the best in class option. The next thing you can do is actually create buildings. So this is that accounting I was talking about, where you are building up your whole project account that might go into a scope 3 report for emissions. This is where it's very similar again to cost estimating. You see you have the lines of the different materials, the quantities, and the units, but instead of multiplying those by a dollar value, we're multiplying them by the EPD carbon intensity value for the products that we used. If you don't have an EPD for the product you used, EC3 will default to that conservative value out of the range, which is very similar to cost estimating, where you're starting with an average or a estimate value. So very exciting that we can actually do that in EC3 too. When you're in a project, you can actually then compare the mixes that you're looking at procuring, pick the one that you actually end up buying, and have the math actually account for that at the project level. And then there's some cool diagrams, like this is called a Sankey diagram, where on the left you're seeing the relative impacts of the ready mix and the strengths versus the rebar versus the insulation. This is actually a project I had my son Jackson do when he was 9 during COVID, and he called it our underground layer for the pug that you saw on the counter. So this is his underground layer, and it's showing that the concrete and the steel, the superstructure of that underground layer, was actually the biggest component of impact. All the way to the right, where you can see the selected material and the reduction that he was able to achieve based on the products he selected with their EPDs. So again, visualizing this, you can start to understand where your bigger hotspots are, but then also track all the way through selection how you did based on the options available to you. So the next thing I love to talk about is just the scale of impact. So when we launched EC3 in 2019, November, right when we were getting ready to launch the nonprofit to take over its development, we had 1,000 people on the wait list. And this is actually a bit dated now. I think we're up to about 49,000 users, but you can see here just the continual increase of registered users of the tool and the database, and the diversity of who those people are. And that's, again, it's all hands on deck. We all have a role to play in this, and the tool is there to help really everyone along that. So really proud of that. The other thing is just the amount of EPDs over time, which again has surpassed, I think, my wildest dreams in terms of how creating this digital place for all this to live, and kind of helping the whole industry move to digital generation of these EPDs versus PDFs has really taken off. And you can see that mostly in the concrete sector right now, where it's on-demand EPD generation. A concrete supplier can get an on-demand EPD generator at their plant, and just for every mix they make, be able to use all the verified emissions data for their plant and their ingredients to push out EPDs that come into our database. And you can see that moment where we went from 900 to almost 20,000 when we turned that on with the first EPD generator, Climate Earth. So just exciting to be able to show all of this. And of course, when it comes to impact, it starts with use and adoption and understanding. So all of these graphs that are increasing, to me, mean that the impact is also increasing. This is just looking at all EPDs across all categories over time and how our database has grown from a North American focused database to a global database, ingesting EPDs from everywhere and anywhere where they're being published. A little bit about that comment I made again, where it's about where everyone's engaged. I showed you the slide about how things are made and how it goes from, on the left, the cement manufacturer to the concrete manufacturer, where they're going to create the information. It's then the general contractor that has to be on board along with the architecture and engineer that are specifying the products to leverage the transparency of the emissions data and make informed decisions, to then give the owner and policymaker the compliance and the reporting that's necessary. So everyone, again, all hands on deck, I can't say it enough, but really it all relies on the fact that we're getting to a place where the data is transparent and robust, and that we're leveraging and promoting the use of EPDs as the best in class source of that data. Just a little bit about understanding the scales and scopes of this. Again, there's tons of acronyms and ways that this stuff is sliced and diced, but just a little bit to kind of ground everyone in what EC3 is able to provide is really this kind of upfront stage of carbon emissions. And that's really, again, the emissions associated with the manufacturing and extraction of ingredients and installation on a construction site. And that's because if you look at the impacts of something like concrete, you can see how much of the impacts are in that production phase. It is important what we do at the end of life of a building if we crush the concrete up and reuse it. But if we're trying to actually reduce emissions urgently, this production stage for the highest impact materials in the construction sector is really the one we have to focus on. And that's how do we get concrete suppliers to do things like look at lower carbon cements, use better aggregate, etc. Same is true for steel. So just an example, if you look at steel production, how much is in that A1 to A3 impact category and why that's a focus of EC3 and EPDs. But if you do want to account for more, and you should, there's the ability to use life cycle assessment tools that include average emissions factors and projections for use in end of life stages of a building to look at things holistically during design when you're doing kind of broad comparisons and optimization. And we have a tool that we were donated by Karen Timberlake called Tally, which is a life cycle assessment tool. And really what this looks like is those life cycle assessment tools on the left, including Tally, can be used during that kind of engineering optimization design phase. And then when you get into specifications and procurement, you pick it up in EC3 to do that cradle to gate manufacturing emissions comparison, leveraging EPDs. So there's a whole ecosystem here. We provide a tool in both places, but there's a whole ecosystem of options that are available to you if you want to dig into this. Just a little bit about Tally. Again, it is a whole building LCA tool. You can download a free trial. You can go into the tool and actually start to do, it's a Revit plugin. So for Tally specifically, our offering is really Revit based, but you can assign all these emissions values to your projects within Revit and then do design option comparisons where you're looking at something like two different cladding options or maybe two different type of infrastructure options. So it's a tool that exists, and I wish I could tell you more about all of it, but I'm going to run out of time. You can hear, I don't know if you can hear Rosie, but I think Chuck the pug might have a bone that she wants. So hopefully it's not too distracting. So just a little bit about the data. Again, I'll share all these slides so you can understand all of it. And what you're seeing here is just really the flow of the data through all the different stages. On the left, there's the data that we use to get to environmental product declarations or generic data that goes in to databases like ours and others that flows into tools that then flows into accounting and flows into compliance. And right now, I just want to ground everyone in this. If you're just getting into this, it can be really overwhelming. And there's people that say we don't have the data we need yet, that the data is not complete. And what I like to say is that we can't wait for perfection, but we can strive for it. So we need to leverage the data we have as we're making it better. So digging into that on building transparency's approach to data, we're not only now trying to provide the tool and the access to the EPDs, but also how do we help fill in the gaps where we don't have data yet? And how do we ensure our mission is accounted for across everything that we do? So we are currently working on a database of global emissions factors that is going to be open and free, just like our EPD database. And it's a project that's called the Open Data for Climate Initiative. I'm very proud of it. Just another example of how building transparency is really trying to be an ecosystem player, providing the data we need so that any tool can provide this accounting to the industry. I'm going to skip that because it's getting into a little bit of the details. But the other reason the data is so important, so I talk about the tool and how you can use EC3 to actually do the accounting, but our database has become something that many other tools and platforms are relying on. And we're getting about 10 million requests of the data annually now. So you can see kind of ups and downs of that. But really, those are people going in and just pulling the data out into their own tools or their own benchmarking platforms to leverage this. The last thing, again, on the ecosystem side, because it's so important to me, is really pointing to everyone that is engaged in this work. It's not obviously just building transparency in what we're doing. Up on the right, when it comes to databases and tools, there's partners here on the screen of folks that are leveraging our database to provide other tools that do this work. We're working together and integrating as best we can. There's examples of the policy that I'll go into for a second to end, just to show you the progress, where we need the regulatory standards, whether it's private companies like the Microsofts and Amazons and Skanskas, or public policies like the US Inflation Reduction Act, or work at the UN, to align around how we really ask and report for this stuff. We need to think about the local and global impacts of some of these materials. Things like concrete and cement can be regional or global, and steel is obviously a very global sector. So how do we slice and dice all of this to make sure we're thinking about this as a global and a local problem and solution? And then up on the top left, all the different NGOs and networks and initiatives that are here to support with resources. Everyone on the screen, if you go to their websites or Google them, will have information for you to digest around environmental product declarations, embodied carbon accounting, etc. So there's a lot going on. We're not in a place now where I think we have to worry about people not knowing embodied carbon exists. I'm hoping that this is helping you learn about it too, but really there's a whole ecosystem of partnerships that are happening to support this. And the last thing I just want to talk through is just how we really do need robust and aligned embodied carbon policies and standards to push all this forward. I'm very proud of the fact that because we've created this open database, that we have been able to inform and work directly with policymakers at both the U.S. and state level, at the U.S. government, the federal and the state level. Also, we've talked with the Canadian government, with the United Nations. There's a lot going on because we can leverage the data we have to help inform policies. And some examples of that, just to walk through here in the US, the city of New York and actually the state of New York too now have embodied carbon policies that require product-specific EPDs for concrete and steel, and ask that you submit those EPDs to the Building Transparency Database using our digital format. And it's so amazing to see that in writing for some of these policies. Another one is at the federal level. There's two things going on. One is the White House putting together a task force called the Bike Lane Task Force that is looking at helping to bring states together to prioritize the purchase of low carbon steel, concrete, asphalt, and glass to ensure that we're aligning the policies around EPDs and everything again. I feel like it sounds like I'm at a zoo. And then the biggest one for me is really the Inflation Reduction Act. And this is where, again, we were able to help support the senators that were helping to write the policies related to carbon of construction materials. And what ended up being in the policy and in the Inflation Reduction Act is over $6 billion of funding for prioritizing low carbon concrete, steel, and glass. And this is how that breaks down. There's $250 million in an EPD technical assistance grant program, $100 million in a program for the EPA to establish a low embodied carbon labeling system, leveraging EPDs, and then over $6 billion of funding across the General Services Administration, Federal Highways Administration, FEMA, et cetera, where they actually get to have a bucket of funding that they can only spend on procuring low carbon materials for their projects. And this is in action right now. The last thing that we're engaged in that isn't just another good point to show that this is global, not just per geography or per government, is the United Nations. There's an industrial deep decarbonization initiative that we're engaged in as technical experts, where countries are signing on to a pledge for cement, concrete, and steel to leverage robust data. There's a guidance out now for the rules that aligns with the US guidance to just really push all this forward at the global scale. And then just one shout out to the private sector. Again, whether you're a private owner or a public purchaser of materials, you can use the same requirements and we can align them. Microsoft was one of our first pilot partners of EC3, and what they did was require project level accounting and low carbon specs and procurement for 9 categories using the EC3 tool, and they set a 30% emissions reduction for their campus. There's a white paper that really talks through how they did that. It's available publicly. And the last thing that's just exciting to me, if I go all the way back to the beginning where I was talking about scope 3 accounting and that spin-based method, the greenhouse gas protocol, which is where these rules are really set for scope 3 standards, has published an update where they are now wanting reporting to shift over to the supplier specific work stream where you're using quantities times actual emissions factors and data. And so to have this now codified in the standards that direct scope 3 means that not only in policies and procurement is this being aligned, but also in the way that the reporting happens on the other end when we're all done. The Science-Based Targets Initiative, which is another thing that many companies are beholden to, also now references that supply chain specific accounting protocol from the greenhouse gas protocol. So it's all there. I got the links to all of this if you want to get nerdy and into the details. But it's just me pointing to the fact that we're getting to a place of alignment. And really, you can distill it down to these 4 things. Require EPDs for the construction materials that you want to start with. Utilize verified EPDs to compare the products and inform your specifications and procurement. Use a tool like EC3 to quantify the amount of those materials you're using and the EPD emissions factors to get to your reporting. And then set targets and reductions that you can actually be beholden to based on that information. So all of that stuff that I just said really distills down to this being the process and the workflow, at least on the cradle to gate, those manufacturing emissions, leveraging EPDs that we can focus on to make true reductions happen. And the last slide I love to show again is based on the data. And this really is where I can go back to my thesis of if we can do these comparisons and we can get to carbon currency and we can ask for this information at time of bid to make a decision, suppliers will start to compete and they'll start to try to reduce their emissions so that they can win the work. And in Washington, where I sit, where Skanska and Microsoft and others were piloting this and starting to require EPDs at time of procurement, with the data in EC3, we can now show that from 2019 to 2023, there's been a 25% reduction in the emissions that have been reported out of EPDs for concrete suppliers in the state. And that's a pretty major reduction when you think about the impact of cement and concrete. To put that into a bigger perspective, if we were just to be able to get to that 25% reduction for concrete globally, it would be the equivalent of sequestering 1 trillion trees. It would be the equivalent of 1 trillion trees sequestering carbon for a year. So this is possible. These interventions exist. The data is there. The tools are growing. And I always leave this with going back to that, putting on your embodied carbon onion goggles. What's stopping you from getting going? I'll stop there.
Wow, what a great presentation. Thank you, Stacy.
I'm sorry about the dog noise in the background, Tim, if it was annoying.
To be honest with you, we didn't hear it.
Okay.
So you must have had them on mute. We also have a dog filter, so we can cut a lot of dog noises out if we need to. Your last slide, what's stopping you from doing it? I guess I'd ask, what are some of the barriers or challenges that exist today in preventing widespread embodied carbon action?
I think the first one that I think a group of us at the NGO level are trying to solve is just the education. So doing stuff like this where there's the awareness of it, I think we can get kind of within our own little bubble and think that everyone must know about this now because we're seeing the growth of it and we've been a part of that growth from the hundreds to the tens of thousands of people. But there are probably millions of people that need to understand this in the construction sector to really make an impact consistently and globally. So just awareness and education, I think, how we do that well. And then the second, I think, is just like proliferation of the data. So I can show all those slides of how much data we've grown, but there are still major gaps in EPD data for things like concrete in certain regions of the US or the world. There are certain gaps in materials that are covered right now with this data. So how do we help other sectors? We're looking at piping and some of those industries right now to help them build the data and create the EPDs so that they can then be assessed and included. I think it's a constant, we're on a journey. The train's going, it's speeding up, and we just need to be building the tracks in front of it so we don't fall off the cliff.
All right, very good. I also want to remind viewers, please submit your questions in the chat or the question thing, and we can ask them here. This one actually comes from Kimberly. She said, I noticed that uncertainty was an output of the EPDs. Are you seeing the uncertainty decrease over the past few years?
Yeah, so this is one of the exciting things that I can say that I think our tool has helped with. So there is uncertainty in EPDs based on how specific the data is, whether it's product or plant. You can have different levels of specificity. And because we've started to show the uncertainty, which I call the blue squishy stuff, around the declared value, people have started to ask why it's there. And in places like concrete, we're now seeing the concrete producers go back and get a cement plant EPD from their cement producer so they can say they have that specific input for exactly the cement they purchased. And that will, of course, reduce the uncertainty. We're also seeing the EPA put out guidelines for the rules around EPDs, what a robust EPD looks like, where they're requiring more specific information in the EPD because they want to reduce the uncertainty and have every EPD that the EPA says is good or can be leveraged by the federal government, make sure it's following those more specific rules. So again, I think that's probably layer 5 or 6 of the onion that we're peeling back, but we are seeing progress.
Excellent. We use a lot of concrete, cement, and steel in the foundation industry. Do you see any cool things happening with those materials?
Yes. So on both cases, first, there's layers of intervention. So I would say the first thing that I think is the easy button that people are starting to become aware of is just moving from prescriptive to performance-based specs, where you can actually let the concrete producers work on the ingredients and the mix of cement and cement replacement and aggregates to meet your performance, but to reduce the emissions. So that's something that anyone can do today as a first step, and we're seeing that work. We have some performance-based specs that you can download from our site. The second one is swapping into a lower carbon cement. So type 1L cement or Portland limestone cement exists. It's what those Washington suppliers did to get a 10% reduction across the board for their entire plant on their mixes. And that's something that's available today too. It just requires the concrete supplier to invest in it. Then we're seeing crazy, wonderful things when it comes to cement alternatives or carbon sequestering cements. Brimstone's my favorite one to talk about as a company that's found a different source of how to make cement that can actually store carbon. The DOE just put out a whole bunch of grants and they won tens of millions of dollars to go build their first plant. There are other things like carbon storing aggregates and things, Blue Planet and others that are in that kind of startup stage. And there's big companies, again, testing, pouring some of those mixes with some of those things in them to do the testing and stuff we need to make sure they'll perform. So we're right there in terms of kind of doing the proof to get some of those solutions out there more at scale. On steel, the thing I'm most excited about, we're here in the States where we've got electric arc furnace plants in many places where at least we are able to reduce the energy emissions associated with those plants through renewable energy and things. So there's Nucor and others doing that. But then the move to hydrogen and some of the ways that we could look at the furnaces and how we actually make the steel, again, are being funded through the DOE at the kind of millions to billions of dollars right now through grants that are out there. So those aren't there yet, but they're beginning to have the funding they need to be tested. They've been proven a little bit more in Europe, and it's just how we start to wait impatiently, I think, for some of that proof to happen here.
Yeah. This is a comment from Rodney Cedillo, or Cedillo, I'm terribly sorry, depending on Amarillo or Amarillo. This is fantastic. Not sure as designers, too many are aware of these tools. We are often asked to create a more sustainable design and reduce carbon. The tool exists. Thanks so much.
You're welcome. And please, I can't do everything I want to in the time that we are typically given to present, but if anyone needs a demo or wants to do a deeper dive or get on a phone call directly with our team at BT to learn more, that's what we do. That's our mission. So please reach out to us.
Charlie's on the counter.
Oh, that's Chuck. Yep.
Oh, can he jump that high?
No, Rosie is a Great Dane puppy. She's 5 months old, but like 70 pounds. So Chuck gets to get on the counter if he needs to escape the puppy.
Makes sense.
Puppy's wrap.
Makes sense. Do you have an EPD for renewable diesel on EC3?
We don't.
Okay.
We have a category for them. Similarly, we actually do have some EPDs for things like wind turbines. But the renewable diesel one would be an interesting one actually to dig into a little more. There's no reason we couldn't create EPDs for that. Yeah.
Okay. does building transparency ensure the accuracy and reliability of the data provided through its tools?
Yeah, I would say it's our biggest challenge in terms of the current, where we have the digital EPDs coming in, where they're just pushed to us magically in our format, and the verifier is the one pushing them to us. We don't have to do anything anymore. But that process of parsing all of this data out of PDF documents, thousands of them, into our format requires some human intervention sometime to make sure the data is correct. And I will say that's why we have public categories of data and pilot categories. So we have to go through each category one by one and do that quality control before we feel comfortable putting it out to the public. And that's a constant just schedule of us working through all those materials. And the more we hear from the industry, the more we can prioritize which ones to focus on next to push out to the public version.
You were showing the EPDs of various concrete suppliers in Washington. You've got certs on all ready-mix suppliers across the country. So if I'm in Rhode Island, I can look up the local producers and pull data on that.
I would say we don't have
data.
We don't have all. I mean, we don't have all. Yeah, and that's again where I talked about the data gap. I think we have these deserts, and if you go, the landing screen of EC3 will let you go in and click to concretes and see by county.
Okay.
Where we have the data. And that's really what the federal government, that grant program that I mentioned, $250 million, that's supposed to go and actually provide grants to the concrete suppliers to invest in the EPD production. It's around, it used to be tens of thousands of dollars. With the competition and the EPD generators, it's somewhere between $1,000 and $5,000 per plant. So it's not an insurmountable amount of money, but in places where concrete suppliers aren't being asked to compete, they need a reason. And the government's trying to help give them at least the funding to take the funding part off of the plate for them.
Yeah, they're certainly not going to go out and spend their own money just for
fun.
No reason. Yeah, sir. We've got some pretty impressive buy clean environments by the U.S. federal government. Is the Canadian government looking at something similar?
Yes. So we have had conversations, and there's work that's been done by the NRC and others to try to help with some of the data collection at the kind of Canadian government level. And then there's good examples. City of Vancouver, BC, has one of the best kind of whole building level policy out there right now. But yeah, we have had multiple conversations with the Canadian government. I know that they are working on this too. And they know about our data, and they're leveraging EPDs.
Mm-hmm.
Yeah.
Can you talk a little bit more about the impact of open access data and how you see access to data evolving in the future?
Yeah, I will tell you, coming from architecture and construction, just trying to basically really solve my own problem with this at the beginning. I'm not a software developer. I'm definitely not a data scientist, but what we've seen happen now, I'm just so happy that we had a tool people could use. But because we could provide the data in an open place and know that it was publicly available, verified data, there are startups now that are building other tools that are trying different ways of helping people do this, same kind of accounting, that don't have to go solve the data problem. They can just leverage ours. So that speeds up the innovation around how we can actually leverage it in tools and platforms to make it more accessible to people. So again, I think our core mission of providing EC3 as a tool has become providing EC3 as a database with a tool. And that database is, I think, again, as we grow it, as we put more into it, the innovation can happen. Maybe EC3 is not the best tool for geotechnical engineers, but someone could go leverage our data to create the best tool if it's not.
I'm sure somebody will come up with a foundation version of this.
Yeah.
It really would be three things you'd have to add: concrete, stone, and steel.
Yeah.
I do want to remind the viewers that if you want a PDH or need a PDH for your licensing, please contact us. I will be churning those things out. It may take a while, but please be patient. But you can certainly contact me or go through Brad for those things. We have run out of questions, and we have had a wonderful time with you. I hope, Brad, we're going to close with another one of Magnolia Steel's great songs.
I feel like that's appropriate, right? I think
Yeah.
Matt's got them queued up, so it'll hit in the playlist after we go off the air. So everybody stay tuned for that. And we can put a link in the chat here in the waning of this fine live program for people to go download the album, listen to it, maybe purchase it. That's kind of a key, right?
That
I guess
sounds
this is
great.
where we do like a support local music kind of thing, right? Despite people being all over the place. But Stacy, thanks for doing this today. It was fantastic. We love having Keller series on, and this was a good choice this year, and you did a great job. I hope everybody avails themselves of these tools that you guys have up on the website. Tim, a fine job as always moderating, and it was fun. For all our viewers, thanks for questions, comments, and for sticking around till the end. If you liked it, and you probably did because you're here at the end, again, click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. Episode number 3 in the series was just announced the other day. It's Tim. Can you pronounce her name? Is it Kadri or
Cabri.
Cabri Lerman Schmidt will be the guest. That will be June 19th at 2 p.m. So you can register for that at Eventbrite, as well as many of our other fine live streams in this summer of live that the GI is having. It is Geopalooza for the next week and a half. Tomorrow we'll be back with a new post from the Geotechnical History blog. We'll have more pit talks from Geo-Congress in Vancouver over the weekend. Next week, we premiere a new show, Foundations. We'll be back with another episode of Director's Cut. There is so much going on. You do not want to miss it. Again, for all of our viewers, thanks for being with us today. Matt Roberts was our producer. Everybody have a great week, and we will see you soon.
Thank you all. Thanks, Charlie, who's been watching us.
Time, you keep on ticking. Life, we keep on living. And oh, we can't escape our selfish ways. No, we can't escape our selfish ways. So we keep on digging our own grave. And seas, you keep on rising. We keep on denying. Oh, till we're knee deep in the waves. Oh, till we're knee deep in the waves. So we keep on digging our own grave. Fires, you keep on burning. Science, we keep deserting. Oh, we can't see through the smoke and haze. No, we can't see through the smoke and haze. So we keep on digging our own grave. No, it doesn't have to be this way. Oh, there's still so much that we could say. Oh, if we stop digging our own grave. We all have one life to live. One day we will die. It's true that life, it is a gift, but we treat it like a right. We all start as little kids, hope bright in our eyes. Then one day our heads grow big, and we slowly lose our sight. And I'm sorry for the harm we've done, and I won't give up the fight. Our swan song is a selfish one, and we're running out of time. Choices that we make, many things that we regret. We say we learn from our mistakes, but I haven't seen that yet. And I'm sorry for the harm we've done. And I won't give up the fight, 'cause our swan song is selfish one, and we're running out of time. A forest burning, species dying, hurricanes churning, oceans rising, and we're still taking everything. A forest burning, children crying, glaciers melting, temperatures rising, and we're still taking everything. So I'm sorry for the harm we've done, and I won't give up the fight, 'cause our swan song is a selfish one, and we're running out of time. When I don't act my age, I drink too much, I stay out way too late. Don't seem to mind where I lay my head. Cause in the morning I'm in a stranger's bed. Cause there are days,
There are days,
cause there are days,
there are days.
and there are days when I don't act so great. I spend too much when I've got bills to pay. I call in sick just because I can. I spend the day with last night's man. Cause there are days,
There are days,
well, there are days,
there are days.
dress real nice, put in my 9 to 5. I go right home, make sure the dog is fed. I drink some herbal tea and I head straight to bed. 'Cause there are days,
There are days,
well, there are days,
there are days,
well, there are days,
there are days,
well, there are days,
there are days,
there are days. Don't give up on me. I know one day I'll be that certain kind of something that you seek. And I won't give up on you and everything we've been through. You know I still enjoy the view. And I don't know where we're going. I've only seen where we've been. And there will be a time over whiskey and wine. I'll finally leave the past behind. It's late and we're awake with the fear of heartache. The scars that years of loving seem to make. The morning you will rise with sleep heavy in your eyes, and I'll still be right there by your side. Cause I don't know where we're going. I've only seen where we've been. Cause there will be a time over whiskey and wine. We'll finally leave the past behind. We'll we keep on living. And oh, we can't escape our selfish ways. No, we can't escape our selfish ways. So we keep on digging our own grave. And seas, you keep on rising. We keep on denying. Oh, till we're knee deep in the waves. Oh, till we're knee deep in the waves. So we keep on digging our own grave. You keep on burning. Science, we keep deserting. Oh, we can't see through the smoke and haze. No, we can't see through the smoke and haze. So we keep on digging our own grave. No, it doesn't have to be this way. Oh, there's still so much that we could say. Oh, if we stop digging our own grave.